Hello everyone, welcome back to our math lesson videos. Today's lesson video is sponsored by Graphics Create. For your graphic designs need, you can find Graphics Create at Graphics Create in Instagram and Graphics Create by Jack in Facebook. This banner is brought to you by Graphics Create. For our lesson today, we will be discussing about the trigonometric ratios. Our objectives for this lesson are: recall the AA similarity theorem, identify the relationship of the sides of a triangle with respect to the given angle, define the 6 trigonometric ratios, calculate the value of the trigonometric ratios in the given right triangles, and determine the trigonometric ratios of complementary angles. The references for this lesson are first, let us review the AA similarity theorem. The theorem says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Suppose we have triangle ABC and triangle DEF, whose acute angles are 30 degrees and its complement. So we have triangle ABC, whose acute angle is 30 degrees, and the complement, which is 90 minus 30, which is 60. And we have created a similar right triangle we named as DEF. So by AA similarity theorem, we can say that these two triangles are similar because they have two similar angles. First one is the 90 degrees and the other one is the 30 degree acute angle. So by the theorem, triangle ABC is similar to triangle DEF. Hence, the following ratios are equal. First, the ratio of side BC to AC should be equal to the ratio of EF to DF. Then, the ratio of AC to BA should be equal to the ratio of DF to ED, and the ratio of BC to BA should be equal to the ratio of EF to ED. Again, using GeoGebra, let us show the given ratio. So first, the ratio of BC to CA is 2, while the ratio of EF to FD is also 2. The ratio of AC to BA is equal to the ratio of DF to ED, and the ratio of BC to BA is equal to the ratio of EF to ED. Now, seeing the ratios in GeoGebra makes us realize that regardless of the length of the sides of any right triangle, as long as their angles are congruent, their ratios are equal or similar. Now let us move to our lesson, trigonometry. Trigonometry is derived from two Greek words. First one is trigonon, which means triangle, and metreo, which means measure. Hence, trigonometry is the study of the measurement of triangles. Now, let us identify which side is the hypotenuse, the adjacent side, and the opposite side. So, first, we need to draw a right triangle, ABC, where angle B is the right angle. And we know the side that is opposite to the right angle is always our hypotenuse. Regardless of the position of where our right angle is, the side opposite it is always our hypotenuse. Now, how are we going to know which side is the opposite side and which side is the adjacent side? We have to first know which angle we are referring to. If we are referring to angle A, or if we are referring to angle C, the side adjacent and the side opposite A is different from the side adjacent and opposite to angle C. Okay, suppose we are referring to angle A. Let us name angle A as theta. The side opposite theta is the side that is farther from the angle. So the side opposite theta is BC or CB. The adjacent side, it is the side that is near to the angle that we are referring to. Since we are referring to theta, the adjacent side is AB or BA. Now, if we are referring to angle C, let's try naming angle C as our alpha. So, if we are referring to alpha, which is angle C, so the side opposite alpha is BA or AB. While the side adjacent alpha is BC or CB. Now, you see the difference between adjacent and opposite side. Now, we are able to identify which side is the hypotenuse, the adjacent, and the opposite. Again, the side that is opposite our right angle is always the hypotenuse. And the side that is not connected or not close to the angle is the opposite side. And the side that is close to the angle is our adjacent side. Now, let us look at the ratio of two sides, same as what we did in proving the similarity of two triangles using the AA theorem. For our ratios, let us refer to this right triangle. The side opposite theta is named as O, the side adjacent theta is A, and the hypotenuse is the side opposite our right angle. When we get the ratio of the side opposite theta to hypotenuse, then we will get the ratio of the side adjacent to theta over the hypotenuse and the ratio of the side opposite theta and the side adjacent theta. These ratios, when translated to trigonometry, are what we know as the constants sine theta for opposite over hypotenuse, cosine theta or cos theta for the side adjacent over hypotenuse, and tangent theta or tan theta for the side opposite over side adjacent. Do not forget the shortcut so, which means that sine is opposite over hypotenuse, ka, which means cosine is adjacent over hypotenuse, and wa, which means tangent is equal to opposite over adjacent. Now, we will get the reciprocal of the trigonometric ratios. We know that sine theta is the ratio of the side opposite theta to the hypotenuse. To get the reciprocal, we have to divide the hypotenuse by the side opposite theta, and that is what we call the cosecant or CSC theta. Now, cosine is side adjacent theta divided by hypotenuse will be hypotenuse divided by side adjacent theta, or what we call as secant. And tangent, which is the opposite side over the adjacent side, will be adjacent side divided by opposite side, or what we will call as cotangent. So let us remember the 6 trigonometric ratios. First up, we have sine theta. Then we have cosine. Then we have tangent. Afterwards, we have cosecant, which is the reciprocal of sine. the reciprocal of cosine, which is secant, and the reciprocal of tangent, which is the cotangent. Now let us have some examples. Using the accompanying figure, show that triangle ABC is similar to triangle EFG by completing the tables. We are going to get the ratio of the sides with respect to or angle A. Now let us have our first triangle ABC, whose opposite sides and adjacent sides are the following. So if we are referring to angle A, the side opposite angle A measures 21 units. The side adjacent to angle A measures 20 units, and the hypotenuse is 29 units. If we are going to get the trigonometric ratios with respect to angle A, we will have the following. Okay, when solving for the trigonometric ratios, we will be using the sides given in our triangle. So first, we will have sine A. Okay, we know that sine is opposite over the hypotenuse, and the opposite side measures 21 units, while the hypotenuse is 29 units. When we divide 21 by 29, we will get this value. Now let us solve for cosine. Cosine is adjacent over hypotenuse. So the adjacent side is 20 units, while the hypotenuse is 29 units. So to get the tangent, we will divide the opposite side by the adjacent side. The opposite side is 21 units, while the adjacent side is 20 units. Or the reciprocal ratios. Reciprocal of sine is cosecant. So we will divide the hypotenuse by the opposite side. To get the reciprocal of cosine, you're going to have secant. And the reciprocal of tangent, which is cotangent. Now let us look at the ratios of the other triangle. So the other triangle will be referring to side or to angle E to get the ratio of the sides. So what we need to prove is that the two triangles are similar by comparing their trigonometric ratios. For the second triangle, we will be referring from angle E, wherein the opposite sides are the following. So the side opposite angle E is 10.5 units. The side adjacent angle E measures 10 units, and the hypotenuse is 14.5 units. Okay, so first we are going to get sine E. As we know, sine is opposite over hypotenuse. Therefore, this will be 10.5 divided by 14.5. Okay. Cosine E, which is adjacent over hypotenuse, okay, and the tangent of E, which is opposite over adjacent, which is, okay, for the reciprocal ratios, cosecant of E is the hypotenuse divided by the opposite side, which is 1.3810. The reciprocal of cosine, which is secant, which is 1.45, and the opposite of, or the reciprocal of tangent, which is cotangent, is 0.9524. Okay, so the cotangent is 0.9524. Let us compare the 6 trigonometric ratios of the two different triangles. Now, if they are equal, that means that triangle ABC is similar to triangle EFG because their trigonometric ratios are the same. So, for triangle ABC, we referred from angle A, and congruent angle A on the other triangle is angle E. So, here are our values. Sine are both 0.7241. Cosine are both 0.6897. Their tangents are both 1.05. Cosecant are both 1.3810. Secant are both 1.45. And cotangent are both 0.9524. Okay. So, you see from our solution that it is true that the two triangles are similar because their ratios are all the same. Okay, so from our solution, we were able to prove that triangle ABC and triangle EFG are similar because their ratios are congruent. Now, let us move to example number 2. Find the value of the 6 trigonometric ratios with respect to angle beta in the figure. First, we have to identify the length or the measure of the sides, opposite, adjacent, and the hypotenuse of this right triangle. The side opposite measures 5 units. The side adjacent measures 12 units. And the hypotenuse is C. So, we do not know yet the value of C. So, using the Pythagorean theorem, we need to get C. So, we know from the Pythagorean theorem that C is equal to A squared plus B squared. Now, regardless of A or B, the two legs are measured as 5 and 12. So, to get the hypotenuse, we just get the square root of 5, square root of the sum of 5 squared and 12 squared. So, which is the square root of 25 plus 144, which is the square root of 169 or 13. Now that we know that the hypotenuse is 13, we can already get the trigonometric ratios with respect to angle beta in this right triangle. So first, we will get sine beta. So sine is opposite over hypotenuse, and the hypotenuse is 13. So it will be 0.3846. While cosine beta is adjacent over hypotenuse, adjacent side measures 12 units, and the hypotenuse is 13 units. And that is giving us 0.9231. Now, tangent beta, which is opposite over adjacent, so we have 5 over 12, which is 0.4167. Now, we will be getting the reciprocal ratios. So, reciprocal of sine is cosecant. So, cosecant beta is hypotenuse over opposite side, and that is 13 over 5. So, that gives us 2.6. Then, secant beta is hypotenuse over adjacent side, which gives us 1.0833. and tangent beta. Tangent beta's opposite is cotangent beta, which is 2.4. Now, let us go to example 2b. Example 2b says, find the value of 6 trigonometric ratios with respect to the angle opposite beta in the figure. So, this is the same figure that we had in example 2a, but here, we are going to get the ratios with respect to the angle opposite beta. So, if we will be referring to the angle opposite beta, we are going to have different values from what we had from the first problem. Since the angle opposite beta is opposite of length 12, therefore, our opposite side will be 12, and the measure of the adjacent side will be 5, and the hypotenuse is still 13. Okay, now we will get the trigonometric ratios with respect to this angle. So, let us try naming this angle as alpha. So, sine alpha is equal to opposite over hypotenuse, which is 12 over 13. And 12 over 13, or 12 divided by 13, is 0.9231. Then, we have cosine alpha, which is adjacent over hypotenuse, and the adjacent side is 5 units divided by the hypotenuse, which is 13, giving us 0.3846. Then, when we get tangent of alpha, which is opposite over adjacent, we are going to have 12 over 5, or 2.4. Okay, we are going to now get the reciprocal functions or the reciprocal ratios. So, reciprocal of sine is cosecant. Cosecant alpha will be 13 over 12 because that is hypotenuse over opposite side, which is 1.0833, while secant alpha is the reciprocal of cosine, so it will be hypotenuse over adjacent. So, we have 13 divided by 5, which is 2.6. And the last one is cotangent alpha, which is the reciprocal of tangent alpha. So, instead of opposite over adjacent, we are going to have adjacent over opposite, which is 5 over 12, or 0.4167. So, from our example number 2, we first get the trigonometric ratios for beta. Then, for example number 2, letter B, we get the trigonometric ratios of the angle opposite beta, which we named as alpha. Now, when we look closely at our right triangle, here, so that this is beta and this is 90 degrees. Or if we get the measure of this angle, this is the difference between 90 and beta. So, 90 minus beta. So, that means when we add beta and this angle, its total is 90 degrees. So, that means that beta and the angle opposite that beta are complementary. When we say complementary, the sum of the two angles is 90 degrees. Now, let us look closely at the values that we got from our solution. Or this solution showed us, so when we have beta, then the complementary angle, which we called as alpha, is 90 minus beta, making the two of them complementary. From our solution for 2a, when we took the trigonometric ratios for beta, these are the values that we got. So, sine beta is 0.3846, while cosine beta is 0.9231, tangent beta is 0.4167, cotangent beta is 2.4. Secant beta is 1.0833 and cosecant beta is 2.6. Now, let us get the result that we got from its complement, which is the angle that we named as alpha, and we know that it is 90 minus the measure of beta. Solution, we can see that sine beta is equal to cosine alpha. Cosine beta is equal to sine alpha. Tangent beta is equal to cotangent alpha. Cotangent beta is equal to tangent alpha. Secant beta is equal to cosecant alpha. And cosecant beta is equal to secant alpha. While sine and cosine, tangent and cotangent, secant and cosecant, they are called as cofunctions. And these beta and these alpha are complementary angles. So from our solution, we can see that cofunctions of complementary angles are congruent or equal. So, suppose that we have sine of 70 degrees, it is equal to the, what is cofunction of sine? The cofunction of sine is cosine. And what is the complement of 70? The complement of 70 is 90 minus 70, so that is 20 degrees. So that means sine 70 is equal to cosine 20, because sine and cosine are cofunctions and 70 and 20 are complementary. While tangent of 50 degrees is equal to cotangent of 40 degrees, because 50 and 40 are complementary and tangent and cotangent are cofunctions. And similarly, secant 43 degrees is equal to cosecant 47 degrees, because 43 and 47 are complementary and secant and cosecant are co-functions. In our next video, we are going to practice the following exercises. Number 1, find all 6 trigonometric ratios of angle alpha in the right triangle shown below. So in this right triangle, our shorter leg is 8, our longer leg is 15. We have yet to find the length of its hypotenuse. So we need to find sine alpha, cosine alpha, tangent alpha, cosecant alpha, secant alpha, and cotangent alpha. Number 2, find all 6 trigonometric ratios of angle gamma in the right triangle shown below. So it has the same measurements. The shorter leg is 8 units, the longer leg is 15 units. So we see here in this figure that angle gamma complements angle alpha. Therefore, their cofunctions are similar or equal. So we need to find sine gamma, cosine gamma, tangent gamma, cosecant gamma, secant gamma, and cotangent gamma. Okay, so that's all for this video. See you again on our next video when we answer our practice activity. Thank you, keep safe, and stay healthy. Bye!